Presented by Caltech.
Thank you for all joining us. It's a great pleasure to welcome Eric Schmidt to Caltech. Welcome, Eric.
Thank you.
We are really delighted to have Eric here.
I did not know that you all had also invented rainstorms in Caltech. I've never seen this amount of water. It must be unique to this physical location.
It is the multidisciplinary strength of this institute. And of course, we wanted to mark the event in a special way. We just hope the river that carries you back north will be effective. Eric is famously the executive chairman of Alphabet, which controls all things Google, and before that, the CEO of Google. And he has really positioned those entities to be innovators in the technology space and to think what's coming next. But perhaps I should let you describe your job in your words.
I was CEO for a decade, which is plenty for your future careers. And now I'm interested in advancing a number of things, including the core investment advancement in science. I spent a lot of time recently looking at the impact of machine learning and AI on science. And I'm very good friends with Richard Murray, who's one of your faculty members, who I view as one of the most incredibly, insanely smart people on the planet. And he encouraged me to come visit.
That's great. We are indebted to Richard in that fashion. So you received a PhD in computer science 35 years ago. Was that the right training? I'm sorry to date you.
Don't remind me.
When
I was a teenager, computer science didn't exist, but I found myself spending all my time on computing and doing nothing else. And when I got to college, I also ignored all the other classes and just did computing. Mm-hmm. So eventually they decided to give me an electrical engineering degree, even though I didn't take any of those classes.
Mm-hmm.
So I guess I didn't really have a choice.
Would you do the same sort of training today?
Well, today I would have a lot more peers.
Mm-hmm. Mm-hmm.
I think today, to me, the most interesting things that are advancing the most quickly would be in the area of biology and, again, in information science, the things that I'm talking about. And one of the sort of principles you want to think about in life is what's new and what's different. And there's always things in vogue, but there are things which really move the needle. And over the years in the industry, I always say, what's the thing that's happening fastest? So for example, it was Moore's Law, although it's slowing now. Mm-hmm. But Moore's Law is what got me my job, my car, my house, the company, and all that kind of stuff. So thank you for Moore's Law.
Well, Caltech takes full credit with Gordon Moore.
Well, more seriously, it's time to thank the physicists who work by themselves or in small groups, because the physics revolution enabled the kinds of things that people like me built things on. And the physicists should thank the mathematicians, because without math, physics wouldn't work.
So is the next revolution the information revolution?
Well, it's been that for quite some time. The biggest shift, if you sort of do the taxonomy of the next few years, next 10 years, you have enormous breakthroughs that are going to happen in personalized medicine, in understanding the brain, in cancer, that kind of stuff. People here working on that at the genetics level and even non-genetics areas because of information. You have things like trying to understand complex systems, autonomy, cities, and so forth. But the biggest shift of all will be in moving up the scale of information understanding. Mm-hmm. In Google, we talk about going from search to suggest, right? So I would much rather, as I'm coming here to visit you all, have Google make a series of suggestions about, 1, this is what you should not say. 2, this is what you said last time and it was wrong, right? The kind of things that a good advisor would give. And we're on the cusp of being able to do that.
It is an extraordinary change and it goes so fast. So how do people assimilate that? Do you worry about that?
Well, one other comment is that the thing that happens is consumer products in this space. The thing that happens next is people's ability to understand and use them. Mm-hmm. And the thing that happens the slowest is government's response to it, right? And I'm not telling you anything you don't already know. You see this all day. Because the governments, whether they're democracies or autocracies, are designed to be inherently conservative. So here we have the most powerful new weapons of information, and we're still not using new teaching methods to teach students using these new methods because we're caught up in the traditional mechanisms of teaching. We don't either encourage or allow the kind of experimentation. So you can understand society as sort of this tip that moves forward, right, which is today being expressed in consumer information services, which is the most visible for all of us. And by the way, it's not perfect. It has all sorts of problems. It can be misused, right, both for political reasons as well as military reasons, as well as bad consumer behavior. But it's the talk of the town. But it takes a very long time for society to adapt to the consequences of those changes.
And I think we're seeing that in our political system
and
right now.
By the way, let me give you an example. The self-driving cars were first funded by a DOE grant, basically in the mid-90s. So that's roughly 20 years ago. The DARPA Grand Challenge, which was won roughly in 2004, 2005, there were 2 of them. Now, how many years ago? That is 12 years ago. And there are these self-driving cars now running around from Google and others. None of you arrived here in a self-driving car without a driver, right? So what is that, 20 years, and you're not about to get one tomorrow?
So you spent time at 2 famous hubs of innovation, Bell Labs and Xerox PARC. Did you adopt techniques from your experience there? Have you modified them? How do you see that experience playing out in your approach?
So I was an undergraduate and summer student at Bell Labs. And when you're a young person, you sort of adopt the belief system of the elders who were impossibly old at 28 or 29. Right?
I remember those times too.
And I just adopted their behavior and mannerisms and belief systems, so I didn't have my own. And Bell Labs, of course, made an enormous contribution. But the most interesting thing was the economic and political creation of Bell Labs by virtue of being a monopoly. And once that monopoly structure was broken, some of the rationale, funding, and stability, which I did not understand was not permanent, came in question, which ultimately led to changes. And today, Bell Labs is not where it was before, but its position in terms of the impact that we see every day, starting with the transistor or the various solar radiations that were discovered and so forth, are extraordinary. I worked at Xerox PARC, which was of a similar nature. Xerox had so much money that they created a research lab, literally because they wanted to spend money on something, and the research lab built the Office of the Future. And the Office of the Future was delivered, but not by Xerox. And so the lesson that I learned was that it's possible for researchers, and these were incredibly smart people. I was like the dumbest and most junior person there compared to all these people. They were all impossibly old at 30, I might add. They got one thing wrong, which is they built one beautiful thing, right? And building one beautiful thing is excellent for getting your PhD, because I did it, right? But it doesn't translate into the kind of impact and ultimately shareholder return. It's interesting as a story that, of course, this is my history, and with Larry and Sergey, who I respect enormously, we were having this debate maybe 6 or 7 years ago, and I said, look, guys, we have all this cash, we have all these earnings, we should build our equivalent of Xerox PARC or Bell Labs. And they said, well, what did they do? And I said, well, they invented this and so forth. But they said, but they didn't translate into anything. So they created a team called Google X, now called X, and which has so far had a couple of big deals and a number of not such big successes. But the important thing is that Google X said, okay, we're going to do research at you guys' level, so very much at the state of the art, but we're going to identify problems that are 10 years out, that can be solved within 10 years, that are at least a 10 times improvement on the existing problem, and can approximate solutions that most people in the world have, right? So very much avoiding the one thing and the two things and the three things, right? Instead of it's the 3 million things or the so forth. So an example is one of the early spin-outs from Google X was something which is now known as Google Brain. And Google Brain is the system that powers all the speech and the voice and all the photographic recognition stuff that you use every day in the Google world. How many users does Google Brain have? If you use that math, I don't know, hundreds of millions, a billion, some number like that. Right? That is a significant achievement. But even more important is that the creation of this opportunity, again, Google Brain, which is around machine learning, created a language called TensorFlow, which we just updated yesterday to TensorFlow 1.0, which includes all the classification libraries that you need to get started on building machine learning systems to do both vision classification and so forth, and start to begin very powerful new systems of learning and concept building. It is literally the key building block. By the way, we gave it out for free in open source, and all of our competitors are using it.
Yeah. Terrific statement. So when you hire somebody into Google X, what are you looking for?
Well, the Google recruiting is sort of famous for its difficulty.
Right.
And it evolved over time. So one of the problems we had is we wanted people who were unique. So they had to have excellent grade point averages, come from the top schools and so forth, and they had to do something odd. So some of our first few people were rocket scientists because we figured that was really hard, right? Not that that was applicable to our job. We liked salespeople who had won an Olympic medal or played in a professional football team because we figured that tenacity, which is an extraordinary skill, think about it, what it took them, is one that would translate into more sales, which indeed it does, by the way, so you want to know. So we've looked for people who are both exceptional in terms of their technological gifts, but also are interesting. And so one of the things that because I travel all around and because the company is now very large, you hear over and over again the comment about the Google people is that they're interesting, that they're clever, that they're creative, right? And it's difficult to do in a corporation. Easy to do in a very specialized university, sort of at the top of the world, which is you guys are. But now imagine doing this for 100,000 people. It gets much harder.
And do you cycle people through different experiences to try to develop that and spread the culture? Or how do you think about that organizationally?
What's interesting is the culture is relatively uniform, largely because the hiring practices are uniform. So there are differences in culture, but if you select for the kind of people who we're looking for, who, by the way, are probably the majority of people in this room, so please join us afterwards to be hired. No, just kidding. But you all
may not take that as a joke, you realize.
Okay. Well, the pay is good and it's not raining up there. But my point is that the kind of people we're looking for are similar to the kind of people that you look for among your students. And indeed, one of the best ways to figure out who to hire is to look at the people who did very well in undergraduate and master's programs in areas that are interesting, right? Because they're likely to be able to want to contribute that. Now, another thing that we do is we have something called 20% time, which allows our programmers, basically technical staff, to 1 out of 5 days a week or 20% of the time do whatever they want. And you sit there and you go, how odd. Partly because in your case, you probably are just project working. You just work on whatever you want to work on anyway. Well, we want to encourage that within some limit. So when we announced this policy, the concern was, well, then they'll go do something else. And I said, look, these are engineers. They're not that wild, right? They're going to they're experts in this area, and they're curious about an adjacent area. And that cycle of freedom has driven the culture, and it allows us to attract people who want that freedom. In the same way that when you recruit a faculty member here, they want intellectual freedom and research freedom. They don't want to be stovepiped in the department of X to do this. And so one of the ways to think about it is, as a management concept, how do you want to be managed? And my guess is you guys don't want to be managed very much, and you'd like to be able to say exactly what you think, and you want to be loud about it, and you want to pursue the thing that you're most passionate about, and in that case, you're going to work incredibly hard. That is our formula.
Yeah, and you're right, it's ours too. I always joke we are self-select for people who don't want to be told at all what to do, which is a management challenge in some ways, but very easy, as you point out, in the other, because they're exploring the world.
And I think in fairness to humanity, most people don't want to be told what to do.
Yeah.
I think the difference is we're talking about people who have their own passion or the thing that they're drawn to. Yeah. It's interesting that Larry Singer and I went to visit Warren Buffett, and his structure inspired us to create the alphabet structure. And he pointed out that the best people to companies, in this case to recruit, and to, in his case, purchase, were companies which were going to do it whether he bought them or not. He doesn't have to manage them. He knows they're committed. He doesn't have to worry about them. He doesn't have to wake up in the morning and say, oh, Johnny, did he show up at work? Right?
You talked about travel and your intensive travel schedule. You've also landed in that travel schedule in some of the most closed societies in the world, Cuba, North Korea, and talked about open internet access. Can you talk a little bit about that and where you think that may lead?
I was hoping to go to Iran, but my invitation may get canceled pretty soon here. One of my sort of personal views, which I think is also reflected in the company's values, is that fighting for an open and free internet is a very good use of everybody's time. It is so easy, especially for a government, to convince itself that this internet phenomena is some American attack on their values and shut it off. Over the years, I'll give you an example of Thailand. So there was a video that was offensive, and by the way, there was one. And so the military government at the time, this is no longer true, shut down YouTube in Thailand for a year. Now, is it possible that they were really offended by this one video? Or is it alternatively possible that all of the information about politics and political speech and so forth was not something that they wanted in their country? So using that as an example, and again, this is an example from years ago, we see this over and over again. So over and over again, I'll end up meeting with the president or prime minister of one of these countries. They're perfectly nice meetings, and they want the benefits of Google, but they don't want the empowerment of political speech in their countries. And that's where we have a disagreement. And so let's say it negatively. Imagine a scenario where, because of this new return to tribalism that seems to be going on, at least around us at the moment, which I obviously decry, and this sort of loss on focus of globalization, which I think is a terrible thing. Let's imagine that the borders begin to shut down on the internet. Literally the free and open exchange of scientific collaboration, cultural collaboration, boyfriend, girlfriend, family, whatever, right? That would be an incredible loss. Remember that the internet was not designed by a set of government committees. What happened was this guy, John Postel, who's unfortunately died a while ago, designed the internet IP structure by saying, well, Russia gets this many, this, so forth, and then 3 other people built routers that interconnected it all. And the then existing telecom operators, without thinking about too much, decided to do essentially free routing among them. So Vince Cerf and a number of other great heroes, Bob Kahn and a few others, basically in secret, that is, by themselves, without being noticed, built this asset, which enabled, right, Apple, Google, Amazon, so forth, and the collaboration that you do every day. Look how diverse this audience is. Think about your families, the interconnections that you have around the world. I cannot emphasize how important this asset is for discovery, for science, for medicine, for the world. And I work hard to make sure that continues.
So since we're talking about transformation and fear, can you comment a little on artificial intelligence?
Well, I'll tell you my current scenario. Okay, so follow this quickly. So what happens is the machines get smarter and smarter and smarter, and eventually they hit a point of super intelligence, and then they become self-modifying, and then what happens is they self-modify, they become evil, and the humans start to turn off the power system, but the self-modified things figure this out, and they keep running ahead of the humans as the humans run around turning off all the machines.
3001, The Space Odyssey.
That, by the way, is a movie script, okay? It's not real, okay? Every single part of the scenario I just said is one made up and unlikely to occur, especially if I made it up in that form. Right? So I say that in order to try to sort of ridicule some of this sort of the so-called experts that talk about this future. Let's talk about where we are. Okay. Today we are able to do human vision and computer vision roughly the same. Computer vision is getting better. Humans will lose that one. Computer speech, human speech, computer speech is getting better, roughly equal. Humans are going to lose that one, right? So it looks to me like we're going to be able to get the things which involve, more accurately, repetitive, low value added activities that involve things like that are likely to be replaced by machines. In the same sense that 20 or 30 years ago, repetitive and difficult jobs in the manufacturing world were replaced by robotics, some of which that work was done here. Get the same idea. So this is not a new phenomena. What is new is that people will spend more time doing things which are uniquely human. Now, okay, so that's pretty good for a while. What do I think? There are lots of fears about AI costing jobs. At least at the moment, I think the evidence is that it creates more jobs. There is a French economist who a long time ago said that basically the problem is we talk about what we see, but we don't see what we don't see, right? So for every one of these narratives that you hear about a job displacement, right, which are legitimate issues, we don't see that the increasing efficiency of the network creates more jobs. The best example, by the way, is ATMs in banks, right? Everyone was very concerned that tellers would lose their jobs. There's more tellers now than ever because the banking industry got more efficient because of the introduction of ATMs. So if you take a view that the world is fixed, that the pie does not get bigger, then you end up in this reductionist argument that somehow we're going to be hurt by this. A better way of arguing this is we're going to make people smarter, that education becomes more important, that globalization becomes more important, and that global sort of ecosystem that we're all part of increases human productivity, increases job growth, increases global income. And I'm quite sure the economics will support me.
So is this where you see Google contributing to the world 50 years from now?
It's it's hard to imagine even 5 years at Google's case. What I would tell you is that today you ask Google questions. What I would like to have is I'd like to have Google be your perfect personal assistant. And again, so we're clear, this is completely secure and completely opted in by you. I'd like it to be able to assist you in getting through your day, right? Because people have incredibly complicated lives. Who do I return the phone call to? Where do I go? Why do I have to learn that again? What was that again? What mistake did I make? In other words, that perfect assistant that helps you become a better human being as you define it. To me, that is the goal here. And of course, along the way, you have to have all the world's information and so forth. There are people within Google who think that what I just told you is not ambitious enough, which I think is, by the way, pretty ambitious. There are people within Google who would say that we would like to do more, that we would like to be able to use these techniques to actually advance the state of science and advance the state of understanding and advance the sort of things more directly, working with human supervision.
So Eric, you've been remarkably frank and articulate, but I know that you are keen to take questions from the audience. So I would encourage anybody who has a question, please, to raise their hand, try to move to the aisles, and there are people with microphones around.
Let's start in the back.
Thank you very much. Very interesting talk. You mentioned that the pie is getting bigger. One of the problems we're having, I think, over the last 20 years is the people slicing the pie have not been entirely equal in allocating where those slices go. Does that concern you, and how do we address that allocation problem?
Yep, it does. And I think it's fair to say, if you look at the economics here, that there is a problem of rising relative inequality. And you see this for many reasons. The simplest way to understand it in our world is that there are increasing returns to knowledge platforms. So if you're a creator of a knowledge platform or a user of knowledge platform, you get a larger audience. But therefore, some other people don't get that opportunity. And so while it's true that everyone benefits, not everyone benefits in the same way. There are lots of proposals of doing that and lots of ways of doing it. And I think it would be unfair to say that there isn't a problem. But I would also encourage you to say that collectively, there are times when we are collectively better off, even if inequality is rising. Because if we're collectively better off, then we can probably use our good judgment, our charity, our tax policies, our education policies to favor people who might not have had as good an opportunity and get them that opportunity for the next generation. And that's, by the way, been true in America for decades.
today. So you mentioned that you really want Google to be able to be your personal assistant, but I know a lot of people right now are concerned about privacy.
Sure.
Even with the tools that we have now through Google or Amazon Echo, Siri, what have you. So how do you plan to address that? And do you think you have like a public relations or public image issue around that?
Compared to our peers, we're doing pretty well in the PR image. What I've learned about privacy is it's an evergreen issue, that this concern will always be present, which is why I gave the disclaimer of this is subject to complete privacy and complete control. And I think that what will happen, a simple example, I'll use an example of the Europeans and the right to be forgotten. So here we are as Americans, and we create this internet which connects everything, and there's no rules about publication. And I've previously and publicly talked about the creation of a sewer of the internet, that there was so much misinformation and bad information, that it's easy to generate misinformation. So the Europeans sit there and they go, we don't want that aspect of this American construction, and so they created a law which is difficult to enforce called the right to be forgotten, which legislatively allows you, if certain facts that are false are published, to get them removed. Without commenting specifically on the right to be forgotten, that's an example of a government regulating what they viewed as an excessive invasion of privacy. We will see more approaches like that, where somebody who's been victimized and so forth. The other thing I would tell you is that if you look, for a while the internet was sort of this entertaining thing on the side. Today the internet is essential to daily life in at least the developing countries and many developed countries and many developing countries. So certainly essential in Europe and in China and the United States and so forth. Each country will approach this problem slightly differently, but at the end of the day, I think you're going to see new social norms evolve, where it's not okay to do that even if it's legal in terms of posting it, precisely because of this issue. And by the way, I wrote a book on this called The New Digital Age.
You spoke before about sort of open access to the internet for everybody, regardless of political issues within governments, but taking a slightly different approach to open access, there are current potential issues of net neutrality rising again. The new chairman of the FCC is taking steps to remove free access to the internet. What can larger companies do to sort of prevent that from happening?
We have largely stayed out of the net neutrality argument. We, Google, are large enough that we're sort of self-neutral in the sense that we are big enough that we can deal with the other large aspects of the internet. So we haven't taken a particularly strong position on this one way or the other. We are generally in favor of more competition and the way you solve these problems by rigorous competition. And that's sort of how we ultimately answer that question.
Thank you. What are your thoughts about uses of augmented and virtual reality as the more effective platform for humans interfacing information systems and humans interfacing with machine intelligence?
We've decided to make a big investment there, and we have this, I don't know if you all have seen this, we have this thing called Cardboard, which is a cardboard glasses that you put your phone in, because all of the previous attempts were very high priced, so that's another example of this high volume, low price approach that we're taking. So we think that over time, the authoring tools will become available for artists and movie makers to make amazing things, and that people will eventually learn how to present other information. That industry is completely dependent upon the volume of the market of viewers and the quality of the authoring tools, and we're announcing them left and right, basically.
I want to know why Google left China. I know that Yahoo has provided the Chinese authority the emails of Chinese political dissidents, causing some journalists to be sentenced to prison terms. I want to know if Google encountered a similar problem when it was in China, and what will Google do to help Chinese people to overcome internet blockage?
So between 2005 and 2010, Google had a subsidiary in China and offered Chinese search Google search in Chinese. In order to do that, we had to comply with their censorship laws. In 2010, we decided that we had had enough of these rules and for various other reasons, including being attacked by the Chinese military in cyberspace, we actually moved our systems to Hong Kong, and that's where we are today. We are in continual conversations with the Chinese government over how we can address some of these issues, and we certainly talk to them a lot. But today, if you use Google Search in China, you're going to use it through Hong Kong and therefore through the Grand Firewall, the Great Firewall, which they have built, which does effectively throttle some Google use.
Singularity University has a lot of the same missions as Caltech, but is structured very differently. What sort of inefficiencies in institutions, academic institutions like Caltech, do you see that we can, overcome?
Well, first place, I think Caltech is a true gem in the world, let alone in the United States. So good job. And I think that I should take a position that we want as many competitors in the Royal Gems scenario as possible. I also think singularity is such an approach. So if you think about the vision of the world I'm describing about, we need 10 versions of Caltech, right? Solving different problems in different places with different leadership and different thinking and so forth. Remember that competition is an element of human behavior, and the competition among scientists drives to excellence and so forth and so on. So I want, to be precise, more funding from the federal government for science. We'll see if that happens. More investment from companies like ours in these areas. A much greater focus in STEM education and all that kind of stuff. You're getting it. By the way, I hope everyone has their phones on. We are in the phone business. Yes. We love your phones. We particularly prefer your Android phones. But isn't it funny that over the years, this just started happening? You'd be sitting in some room, and all of a sudden there's this alarm, and everyone says, "Oh, the building is burning down." Thank God. First, it's raining; it's not going to burn down. I do have one, just if I could hold forth on one other issue here. I think that there's a possible change in technology and science, and you and I spoke about this, so you can sort of interpret into the language of Caltech, that traditionally scientists, especially at your level, have had, they sort of wake up in the morning and they have some incredibly detailed thought, which they program down. They have a hypothesis, and they build algorithms and test it and so forth, and they eventually get the Nobel Prize. So good job, as I said. There's a new model for how to do science that we are trying to propose that ideally you all would begin to use, which has a different starting point. It's get as much data as possible, and then without too much of a theory, begin to analyze the data. The phrase here could be hypothesis-free. Now, if you went to your faculty member and you said, "I have a hypothesis-free approach," he'd say, "Well, you have a free ticket out of Caltech." Okay, so you might want to say it in a different way, and I'll let the president describe how to do this. But the new technology should allow you to use data approaches that will generate hypothesis-free solutions that will be incredibly interesting, right, and transformative. And I will further say, with the bias, and we're clearly on one side of this, that there are many, many very difficult problems in science that might be solvable through our kind of a machine learning approach that have not been solvable in 100 years by your traditional approach. Mm-hmm. Did I say that accurately, or you want to retranslate that into Caltech speak?
No, I don't think I need to retranslate, but I would ask, how do you go from the correlations to the causation, or do you not care about that?
It depends, right? That's a very good question from a physicist, I might add.
Yes, right. The old way of approaching things. Yes, right.
But let's say that as a result of this data analysis, you came up with a correlation that you then set out to prove that was not in your initial hypothesis. Mm-hmm.
Yeah, that would be extraordinarily valuable.
That might be a way to move science forward. So the eventual, another flood watch. Yeah. My eventual goal would be to imagine a situation where you have a physicist or a chemist, super smart people, and you have a computer that's been fed physics and chemistry. And the physicist wakes up in the morning and has a hunch, and he types, my hunch is A, B, C, D, and then the computer, with his vast knowledge of physics, can begin to do reinforcement learning and other approaches, various forms of scenario planning, to come back and say, your hunch is probably not true, but you might have a hunch over here, okay? And so then the physicist says, has a coffee, right, thinks about it, and then gives the next hunch, right? And so this symbiosis, if you will, between this incredibly disciplined thinker and the ability to look through vast amounts of knowledge and data is the future. Now, in math, people have been doing math, essentially math programming aids for a long time. So they'll have some mathematical test, they'll sort of code it in some interesting way and so forth. This is the next logical step, but it's applicable chemistry, physics, geophysics, math, computer science.
Well, with this glimpse of the scientific future, I think we should thank Eric for just an incredibly
thank you all.
stimulating